So for our next unit, Unit 4, we are going to be talking about the scientific revolution, the Enlightenment, and the Age of Exploration, and kind of the events that were happening in this time period. This looks at the time period from about the 1300s to about the 1800s. So a pretty good span of time, also relatively around the same time period that the Renaissance and Reformation were happening. So some of the events of this time period are going to be kind of overlapping with those previous events that we discussed in our last unit. So we're going to see how some of those ideas also that we learned last unit tie into this new unit. So for section 1, we're going to start by talking about the event known as the scientific revolution. So for the first EQ, we want to talk about what was the scientific revolution. And so to begin, the scientific revolution was really caused because of humanism, which we talked about and learned about in our previous unit about the Renaissance. So for the first bullet, we want to say Renaissance humanists studied the texts of Latin and Greek, scholars, and scholars is spelled SCHOLARS, scholars, and scientists like, and then if you look on the right-hand side there, their names are Ptolemy, then put a comma, Archimedes, comma, Plato, comma, and Aristotle. And so maybe you've heard of some of those individuals before. They were many of these kind of great thinkers of ancient times, of, Latin and Greek individuals that were thinking about how the world worked and how government worked and those different types of things. And they were some of the first to kind of try and make some what we would consider scientific discoveries of that time. So previously, many individuals always kind of referred back to those old texts to learn from kind of the great thinkers of ancient times. Now with humanism, if you remember, we talked about how humanism was challenging people to think for themselves and create and think outside the box a little bit. And so that is going to make many of the thinkers of this time period start to kind of question some of those previously accepted ideas. And we're going to see a lot of growth in some new kind of scientific areas. So that's what we want to write for our second bullet. We want to say, this inspired new thinkers of the 16th and 17th centuries who began to question previously accepted ideas, and began to make new discoveries, in mathematics, which is up on the screen in the bottom for you, comma, chemistry, astronomy, anatomy, and technology. So many of the different scientific disciplines that we use today, some great ideas came about during this time period thanks to kind of this new Renaissance humanist thought. So let's talk about some of these new ideas, as well as we'll start by talking about some new inventions that are going to come along to aid in kind of this advancement in this time period. So now for our second EQ, we're going to talk about 3 inventions of this time period. The first one was the microscope. Now, probably all of you have used the microscope before, but the purpose of a microscope, let's put this in the box next to its name, is to magnify objects that were very small. Magnify objects that were very small. So this is going to be especially helpful in some of the fields that we mentioned before, like chemistry, anatomy, as well as also biology. So microscope is our first invention. Second is the invention of the telescope. Now, probably all of you have seen a telescope before, or maybe used a telescope. And this invention magnified objects that were very far away. Magnified objects that were very far away. So this technology was going to aid very much in the study of astronomy, which is studying the planets and other kind of heavenly bodies of the universe. The last invention is what we call the chronometer. And the chronometer is a technology that allowed for explorers to keep time and calculate their ship's position. So this was a technology where it was going to be something that was going to start to become very common on a lot of ships that were used for exploration, and it allowed for them to keep time better, as well as be able to calculate the position of where they thought the ship was in relation to land and other things. So this is kind of like an old version of GPS. So I might write in that same box GPS-like to help us kind of make a connection to something more modern that does a similar type of job. So these 3 inventions were going to be very helpful in this time period, both with the scientific revolution and also the age of exploration, which we'll talk about later on in section 4. So that takes us to looking at what were some of these new scientific ideas that came about during this time period. So what I've done is kind of broken it into different categories that we'll talk about. So the first category we're going to talk about is mathematics. So under mathematics, we're going to talk about 4 kind of new ideas that came about during this time period, or mathematic disciplines. So the first one is the concept of using letters to represent unknowns. Using letters to represent unknowns. And this is a common practice that we see with the mathematic discipline of algebra. So many of you might be familiar with this type of idea of solving for, an X variable, something that you don't know, and trying to figure out what that variable, is representing. And that concept came about during this time period. A second type of mathematics that came about during this time period is what we call trigonometry. Trigonometry, which is in the bottom kind of center of your screen. And trigonometry is kind of like a mix of both algebra and geometry. So it's kind of a more advanced mathematics. So this concept comes about during this time period, as well as also what we just mentioned, geometry, which some of you also might be familiar with, which is understanding angles and different shapes and things like that in mathematics. And then the last type of mathematics is what's called logarithms, which is in the bottom right corner. And logarithms is basically a really advanced kind of solving for mathematical values. Something that's done a lot of times in upper level kind of calculus classes and things like that. So logarithms also came about. So we have a lot of growth in mathematics in this time period. So those are 4 different concepts that come about. The second area that we see a lot of growth in scientific ideas is in the field of astronomy, which we mentioned before is kind of the study of like our planets and solar system and comets and all those types of things. So to start, I want to kind of explain what the belief was prior to the scientific revolution. So before this whole kind of revolutionary idea, what did kind of the ancient Greek and Romans and people leading up to this believe about our universe? So we want to say prior to the scientific revolution, scientists supported what we call the Ptolemaic geocentric system, which is up there on the screen for you. Supported the Ptolemaic geocentric system. And then we want to define that as which is the belief that the Earth is the center of the universe. Which is the belief that the Earth is the center of the universe. So prior to the scientific revolution and some of these new ideas that are going to come about, most people all thought that our universe revolved around our planet Earth, and that everything else, the sun and the moon and all of the other planets, rotated around our planet. And this was kind of the commonly accepted idea. A way to help you remember this long term, geocentric, is think like geography or geology, which are all studies about the Earth, and then centric, like center. So think Earth in the center. Now, this belief was also the belief that the Catholic Church supported. They also believed that the Earth was in the center because their theory and what kind of the scripture was saying was that because man was created kind of in the image of God, naturally our planet, which contains man and is supposed to be kind of God's greatest creation, would be smack dab in the center of the universe. It has to be. And so I would make a little note in that same bullet that you want to either put a semicolon or in parentheses, and we want to say was also supported by the Catholic Church. Was also supported by the Catholic Church. So this is kind of the common belief pre-scientific revolution. That is until our first astronomer comes along, and his name is Nicholas Copernicus. And so we want to say, after his name in our notes, that Nicholas Copernicus argued a heliocentric system, which is up on the screen for you, a heliocentric system with the sun being the center of the universe, with the sun being the center of the universe. And this went against the geocentric model. And this went against the geocentric model. So Copernicus comes along and he says, no, I don't think that the Earth is the center of the universe, but instead I think that the sun is the center of the universe. Now, all of you that have had any basic learning about our universe and solar system know that all of the planets revolve around the sun. And Copernicus was the first individual to present this idea, which we understand as common scientific knowledge now. So initially, this was kind of his idea to present this findings. Now, not all people were going to accept this belief. We'll see that more a little bit later, but he's kind of the first to present this idea. So then other astronomers come along and kind of build on this idea and kind of also confirm the heliocentric universe. So our next person is Johannes Kepler. And we want to say about Kepler that he added to this idea with his argument that planetary orbits, planetary is spelled Planetary, planetary orbits were elliptical. An elliptical is up on the screen for you. An elliptical is simply a term that means egg-shaped. I might write that in parentheses after it, where elliptical or egg-shaped. And then we want to put a comma, and we want to say not circular. Not circular. So where previously, if we go back to kind of this picture, they believed that all of the planets rotated around the sun in kind of this perfect circle. Well, Kepler said, well, yes, all of the planets do rotate around the sun, they actually do so in an elliptical orbit pattern. So this is going to kind of further extend that idea that Copernicus had presented and build upon it to present kind of this new idea. And we know that this is factual from information today. So we can see kind of the growth of this idea. The next individual is going to be someone we're going to look at a little bit more closely later, which is a guy named Galileo Galilei. Now, Galileo is also kind of something unique, is he is commonly referred to in history by his first name, where most people in history are referred to by their last name. Everyone kind of talks about him as Galileo. And so we want to talk about his contribution. So we want to say that Galileo Galilei used a telescope to discover that planets were not made out of light, comma, but were material substance. So Galileo challenged an idea where previously a lot of individuals were not understanding kind of what the material makeup of our different kind of planetary bodies were. And Galileo was some of the first ones to kind of look at those planets and the moon and be able to explain that they were actually physical matter, like our moon, that it's a big rock and that there's, more to it than just kind of like it being an orb of light or like a star or a comet. So that was something new of that time. Now we're going to come back to talk about Galileo a little bit later and some of the conflicts that he's going to get himself into that we'll discuss more in EQ5. Our last astronomer is someone you've maybe heard of before, which is Sir Isaac Newton. And what we want to say about Isaac Newton and his idea is that he explained why the planets orbit around the sun orbit around the sun, and how motion occurs on Earth, using gravity. Using gravity. So Newton's contribution is he is going to be able to explain why the planets all circulate around the sun and how on our planet motion occurs using the concept he is going to develop, which is the concept of gravity. The reason why, when we drop objects, they all fall to the ground, and why our Earth doesn't just go slingshotting out into the universe, that the force of gravity draws it in. So that concept is going to be something that Isaac Newton is going to introduce during this time period as well. So we can see also a lot of growth in the field of astronomy. The next field is the field of anatomy. Now, some of you might be a little familiar with anatomy if you've taken any of the health sciences classes. So one of the people we need to mention of this time period that was really significant to this field is a guy named Andreas Vesalius. And what we want to say about him is that Andreas Vesalius was the first to present detailed anatomical drawings. Detailed anatomical, and I'll spell that for you, ANATOMICAL, anatomical drawings of the human body, including the skeletal and circulatory systems. And that phrase is up there on the screen for you in the left. Including the skeletal and circulatory systems. So Vesalius is going to carefully study the human body, and he's going to be the first person that's going to do a lot of very detailed drawings of our human body and help people better understand how the body works and the different systems within the body, whether it be our muscles or our bones or our nerves, all those different types of things. He's going to kind of carefully examine that and make these drawings, which help people kind of better understand how the body works. And many of his drawings are still commonly used in a lot of medical textbooks even today. So they have had a huge impact on the study of medicine and anatomy and the physical form. The other contribution and idea that we want to write about that came about during this time period was a belief that they started to transition to in this time period. Now, this is going to sound strange, but this is actually something that they had believed. So for the second bullet, we want to say the belief that the heart circulates blood throughout the body, comma, not the liver. Now, previously, they believed that your liver was the organ that moved your blood throughout your body. Now, while the liver is still kind of within your central core of your body, that was what they thought was a very vital organ for survival. They didn't realize that the heart actually was the organ that was pumping your blood throughout your body. So that was a really important kind of change that they had in this time, thinking about the body differently because of that. So that was a huge growth of this time. The next field we're going to discuss is chemistry. And so with chemistry, we're going to talk about what's called Boyle's Law, which is based off of Robert Boyle. So we want to say Robert Boyle's Law explains how the volume of a gas varies, varies with the pressure applied. Varies with the pressure applied. So this is a concept in chemistry. If you're looking up at the screen, if you look at kind of the yellow areas, the yellow area is showing you what we would consider kind of the volume of a gas. And if you notice on the left, the volume of the gas is at 4. And as you kind of change the volume, so for example, going from a 4 to a 3, you'll notice that the molecules and the particles that are there in the yellow, those little dots, as you decrease the volume, make the volume less, those particles have less room to move around in, which means that they're going to have more collisions with each other. Because of that, what that does is it means that because there's more collisions, it's going to increase the pressure of that gas. So if you notice, the volume that has 4 has a pressure of 1, where the smaller volume has a pressure of 1.33. And that's because there's less room, so those particles are having more collisions. So that is what we call Boyle's Law, which helps kind of explain that common chemistry concept. The last scientific idea that we want to mention is something that is used all the time in science, which is the scientific method. So under scientific method, the individual who came up with this concept of the scientific method is Francis Bacon. And so what we want to say about Francis Bacon is we want to say he created a step-by-step approach, to solving problems through observation and experimentation. So many of you are familiar with the scientific method. If you've ever done a science fair project or anything like that, this is the step-by-step process that all scientists and problem solvers follow in order to try and figure out the answer to their question. So this is kind of a foundational idea that came about during this time period. So as you can see, lots of new scientific ideas come about during this time period. Now, we also want to mention that there were a few women that made contributions to this time period, so we want to mention them as well. So the first one is a woman named Margaret Cavendish. And so what we want to say about her is that she wrote a book criticizing is CRITICIZING, criticizing the thought that humans understood all of the natural world. Humans understood all of the natural world. So what's unique about this idea, and this is going to be one of the things we'll see here in a second with the article you're going to examine, but people of kind of the previous time period very much believed that all of the answers to, life were already figured out. And that religion and kind of their science of the time was able to answer all of those questions. Now we know today that there are still many questions of our, world and our existence that are unanswered. And so Cavendish very much argued that we still as human beings had a lot of investigation and scientific discovery to do, and that we weren't done just coming up with new ideas. So she was very kind of advanced in realizing that there was still a lot to do in science and technology and innovation and so on. The other female that we want to mention who was contributing was Maria Winkelmann. And Maria Winkelmann was an astronomer, Astronomer, an astronomer who discovered a comet. Was an astronomer who discovered a comet. So she was also someone that was going out and looking at kind of the astronomy of this time and making some contributions there as well. Now, one thing that's important for us to mention about the women scientists of this time is that they oftentimes weren't credited or given the same opportunities that kind of the male scientists were, which is still very kind of common of this time period, that we see men and women not being treated equally or fairly in society, just because there are still very strong patriarchal societies in Europe in this time period. So we want to say for the last bullet, many women scientists of that time were not given the same credit as the men, comma, and were often overlooked for academic positions at the universities. Often overlooked for academic positions at the universities. All right, so now we are going to do a little activity looking more at the topic we're going to be investigating in EQ5. So what you're going to need to do is take your notes that you've taken this far and take your packet and your checklist up, and you want to show them to me so I can sign off on your completion of part 1. I'm going to then give you a blue paper. You'll want to put your name on it, and then on Canvas you're going to want to open up the document that's called Galileo Reading, and you're going to want to read through that article and use the article to answer the questions on your paper. Now, on your paper, you do not need to write incomplete sentences. However, you still need to write enough to provide response to the questions. Now, some of the questions ask you maybe 2 different things, so make sure you're answering both questions. So you'll go through, the questions pretty much go in the order of the reading, so just read it from beginning to end and follow along answering your questions. And then when you are done with the blue paper, you want to bring that and your checklist back up to me, and I'll sign off on that and take your blue paper. You can then watch the second part of the Scientific Revolution notes, which will help you respond to EQ5. So go ahead and do this now.